Okay, so now we're going to take the Algebra 2 column proofs. Now we're going to do some geometry stuff. We're going to start with the most basic shape that we can talk about things with some kind of detail, and that's the segment. All right, so given EF is equal to GH. So EF equal to GH, tick tick. EF equals GH given. Alright, and then this proof right here, it told me that I added FG to both sides. That's pretty cool. Alright, and that's addition property. When you add something to both sides, it's addition property. Now what's really neat is we're going to look at this stuff right here, such as EF plus FG equals EG. EF plus FG equals EG. Similarly, I'm saying GH plus FG, GH plus FG equals FH. When I'm adding two smaller segments, so the left part and the right part to equal the whole thing in both these cases, it's a segment addition postulate. So yes, in both steps we're adding segments, but one's addition property when we do it to both sides, one's segment addition postulate when you're adding the two smaller segments to equal the whole thing. Alright, and these minor details, these are great life skills to look at, be able to analyze, differentiate between details, and comprehend stuff. Now, this next one's a doozy. Why? Look at this. Alright, we'll use yellow so it's not too overwhelming. But we have EG is equal to EF plus FG. Well, EF plus FG is right here. So we got a bunch of things that are equal to each other. So sometimes we can also think of transitive as just a train of statements. So I can go from literally EG, actually let me pick a different color. I can go from EG and I can get all the way to FH because a series of statements are equal to each other and all that fun stuff. So transitive. And then where I want to end up at is saying, well, the two segments are congruent to each other. EG is congruent to FH. And when I go from congruence to equals or vice versa, it's always definition of congruence, right? So in statement 4, we're saying EG equals FH. That's saying that they have the same length. If I measured them out, they would have the same length. In statement 5, saying EG is congruent to FH, that's just saying the shapes are the same. The shapes themselves are the same. Alright, then we got this one right here. So given AC, basically it's saying given AC is equal to AB plus AV. Interesting. A little quirky. I've seen a lot of stuff similar to this, but I'm not sure if we've ever seen this exact one. Given. Alright, statement 2 is now, this is a little bit more familiar. I'm saying, well, AC is equal to AB plus BC. And that's just good old segment addition postulate. Alright, now, next, AC equals AB plus AB. AC equals AB plus BC. So all this junk equals each other because they both equal AC by transitive. So remember, you kind of start to notice that these proofs just have kind of one big pattern where there's only a certain amount of things you can pick. Segment addition postulate, transitive. Those are just a couple to name a few. And then how AB and AB is eliminated from both sides, it's because I subtracted it. And boom. That's it. That's the proof right there. Alright, let's keep cruising right along. We got 2 more proofs to do. So statement 1, given A and B are right angles. Alright, so angle A, angle B are right angles, and that's a given. Okay, now we can say the measure of angle A is 90 degrees and the measure of angle B is 90 degrees by definition of right angle. And then again, they both equal 90 degrees, so they equal each other. If A equals 90, B equals 90, measure of angle A must equal the measure of angle B by transitive. So even now we're doing angle proofs, very similar to the segment stuff we were doing. And then lastly, what I want to prove is always my last statement. So if measure of angle A equals the measure of angle B, angle A is congruent to angle B by the definition of congruence. Nice. Alright, and then one last proof, and then we're done. Angle L is supplementary to angle M. So I'm just going to kind of circle them both together and write 180. Alright, that's not really any official geometry notation, but sometimes we got to just do what works best for us, what we understand. Same thing right there. Alright, so that's helping me visualize, well, these top two angles add up to 180 degrees, the bottom two angles add up to 180 degrees, and next it's telling me angle L and angle O are congruent. Let me use a different color for that one. Alright, so we need to basically prove that angle P is congruent to angle M. And me personally, by drawing on my picture, it becomes very obvious that in fact they are. Maybe for you too. But the way it's obvious in our brain, now we have to take our thoughts and translate them to words, which is a good life skill to have. Articulate our critical thinking skills, articulate our thoughts, explain what we're thinking. Alright, this is good stuff. Alright, so statement 1, very long, angle L, angle M are supplementary, angle P, angle O, supplementary, and then angle L is congruent to angle O, given. Alright, we'll be a little tedious right here, and then like this could almost be 1A, but we'll call it 2. I'm going to say the measure of angle L equals the measure of angle O by definition of congruence. So I just used the previous statement there. And I'm also going to use buzzwords. Buzzwords are going to help me for number 4, supplementary. Okay, so sometimes we're going to hear words we know stuff about, and we're going to use it. It's telling me L and M are supplementary, so measure of angle L plus the measure of angle M is 180 degrees, and same stuff for P and O. Since they're supplementary, the measure of angle P plus the measure of angle O equals 180 degrees by definition of supplementary. Buzzwords. When you see a very famous word, so let's just write out stuff we know about it. Now this might blow your mind, but all this junk equals 180. All this junk equals 180. So since they both equal 180, they must equal each other. Why? Transitive. Alright, so again, I'm going to use previous statements. These two angles equal each other, so I'm going to substitute O for an L. I'm going to swap it out. That's mathematically legal. So now I'm going to have the measure of angle L plus the measure of angle M equals the measure of angle P plus the measure of angle L. And all I did was sub, sta, to, Sean. Alright. Now, keep cruising. I got this angle L on both sides. Let's get rid of it. What's a good way to get rid of it is just subtract it. Since it's a positive angle L on both sides, I'm going to get rid of it via subtraction. And since this is the last proof, our last opportunity to review, let's be incredibly tedious, precise, all that fun stuff. Is I have measure of angle M equals a measure of angle P. But if I look at my what I want to prove, they need to be congruent. Alright, so whenever I go from equals to congruence or congruence to equals, it's always definition of congruence. And then again, being super duper tedious on this proof, as precise as we can be, is we're going to swap the order so it fits what we want to prove exactly. And when I swap the order, it's symmetric. And whew, we are done. All right, so remember, other good ways we can prepare and study for tests is obviously this review. Practice problems, just do them again. It keeps the highest score. All right, rewatch some videos. If you're not feeling good about angle proofs, why don't you just watch some videos? You don't even necessarily have to write things down this time. You can just listen to it, or you can redo all the notes. All right, quizzes keep your highest score. There's a lot of resources, iBooks. All right, so make sure we're prepared, make sure we do well, and good luck on the test. Have a good rest of your day.